how to obtain a formula for an inverse. 1, we replace f of x with y. 2, we switch x and y, or interchange them. 3, solve the resulting equation for y. And 4, replace y with f inverse. Example, determine whether the function is 1-to-1. If it is, find a formula for its inverse. Function is f of x equals 2/3 x minus 4. So first, I'll replace f of x with y, so that I have y equals 2/3 x minus 4. Next, I will switch x and y, so that this becomes x equals 2/3 y minus 4. And we'll solve that resulting equation for y. So in this case, x equals 2/3 y minus 4. To isolate y, I need to add 4 to both sides. So this would be x plus 4 equals 2/3 y. And then I will need to multiply both sides by the reciprocal of 2/3, which is 3/2. So I have 3/2 parentheses x plus 4 equals 2/3 y times 3/2. Now distributing that 3/2 means I have 3/2x, and then 3/2 times 4 would be 6, so 3/2x plus 6 equals y. And last, I'll replace y with f inverse. So I'm going to change the order as well, so that this is f inverse of x equals 3/2x plus 6. My next example, my next slide, determine whether the function is 1-to-1. If it is, find a formula for its inverse. And I need to go back, actually, that last example didn't necessarily determine that it is 1-to-1. But that function, that f of x equals 2/3 x minus 4, is a linear function with a positive slope, so it's always increasing going from left to right. So because it doesn't change direction, the horizontal line test would determine that it is 1-to-1. Now, to the function f of x equals x cubed minus 5, I know that a cubic function, x cubed, is going to, just like a linear function, since it has a positive a value, it's going to increase going from left to right always. So this is, in fact, going to be 1-to-1. Now, we want to find the formula for its inverse. So first, I'll rewrite f of x equals x cubed minus 5 as y equals x cubed minus 5. Then I will replace x with y and y with x, so that I have x equals y cubed minus 5. And we want to solve for y, so I will add 5 to both sides. I have x plus 5 equals y cubed. Now, why it's important that it's 1-to-1 is what's going to happen here. I'm going to take the cube root of both sides. I have x plus 5 equals y cubed. So to isolate the y, I will take the cube root of both sides, so that y equals the cube root of x plus 5 quantity. Finally, we'll replace y with f inverse of x. F inverse of x equals the cube root of x plus 5 quantity. For our final example, find the inverse of the 1-to-1 function. Now we are told this one is 1-to-1, so we don't have to concern ourselves with that, but it's f of x equals, and we have a numerator of x plus 1 and a denominator of x minus 7. So the first thing I will do is replace f of x with y, so that I have y equals numerator of x plus 1 divided by denominator of x minus 7. Second, I will replace y with x and x with y, so that this is x equals numerator y plus 1 over denominator y minus 7. Now what I'm going to do next is a very common tactic with functions like this. I'm going to multiply both sides of my equation by y minus 7 because it's the denominator, the expression in the denominator. So I have y minus 7 in parentheses times x equals y plus 1 over y minus 7 times a quantity y minus 7. On the right-hand side, those two quantities simplify, so we don't have to write that. So the right-hand side is y plus 1. The left-hand side, if I distribute the x term, will be xy minus 7x. Now I want to isolate y, so what I need to do is get all of the y terms on one side and all the terms without a y on the other side. It seems to me it'd be easier to move my y terms to the left side, so I will subtract y from both sides. So I have xy minus 7x equals y plus 1. I'm going to subtract y from both sides. I'm also going to add 7x to both sides. This results in xy minus y equals 7x plus 1. Now I did this because I want to isolate y. I'm going to factor y out of the left-hand side. So xy minus y, if I factor a y out, that is y multiplied by the quantity x minus 1 equals 7x plus 1. Now to isolate y, I will divide by x minus 1 as a quantity, so that y equals 7x plus 1 as a numerator over x minus 1 as the denominator. Finally, we'll replace y with f inverse. So f inverse of x equals a numerator 7x plus 1 over a denominator of x minus 1. I'd also like to note that the original function's domain was x not equal to 7, it had x minus 7 in the denominator, where our inverse has a domain of x not equal to positive 1 because the denominator is x minus 1.